Find the derivative of g of t equals to t times 2 over t plus 6 over t squared. Then evaluate g prime of negative 3. So g of t is made up of the product of two functions, t times 2 over t plus 6 over t squared. We can physically take the product, though, to avoid using the product rule. So we can distribute that t in there. That will give us 2t over t plus 6t over t squared. For the first term, we can cancel the t's out. For the second term, we can cancel the t in the numerator with one of them in the denominator, not both of them. And that means g of t can also be written as 2 plus 6 over t. That first term is just a constant. The second term right now is a quotient, but the numerator is a constant, so let's bring the t to the numerator as a negative exponent, and it will be 2 plus 6 times t to the negative 1. And that means that second term can follow the power rule for the derivative. Let's take the derivative. G prime of t is going to equal, the first term is a constant with no t's, derivative will be a 0. The second term will follow the power rule, bring the negative 1 down, multiply with the 6. That will give us negative 6 t raised to the, and let's subtract 1 from the exponent, minus 1 minus another 1 is a minus 2. Now since we have a negative exponent, we're going to move it to the other position. It's in the numerator right now, let's move it to the denominator. And we have negative 6 over t squared for the derivative. The other thing we need to do is evaluate g prime of negative 3. G prime of negative 3 means to take the g prime of t and plug a negative 3 in for all of the t's, which will give us a negative 6 over negative 3 squared. We need to square that negative 3. Negative 3 times negative 3 is a positive 9. So negative 6 over positive 9, which have a common divisor of a 3. So we'll divide 3 into each of them. 3 into 6 is a 2. 3 into 9 is a 3. And we end up with negative 2 over 3.